Hello everyone, I am Avinash Koda. Today I am going to explain some of the most important topic in analyze and design thinking, that is insertion sort with time efficiency. I start with the introduction. Introduction to insertion sort. Insertion sort is a simple sorting algorithm that builds the final sorted array one element at a time. It is efficient for small data sets or nearly sorted arrays. The time complexity of insertion sort is 0 n to the power of 2 in the worst case scenario. How to insertion sort works. The algorithm iterates through the array, comparing each element with its adjacent elements. It shifts elements to right until the correct position is found for the current element. Insertion sort is a place sorting algorithm, meaning it does not require any extra storage. But best case time complexity. In the best case scenario, when the array is already sorted, insertion sort has time complexity of 0 of n. Each element is compared with its previous element and no shifts are required. This makes insertion sort efficient for small or nearly sorted arrays. Next, second one is worst case time complexity. In worst case scenario, when the array is sorted in reverse order, insertion sort has a time complexity of 0 of n to the power of 2. Each element needs to be compared and shifted to its correct position. This makes insertion sort less efficiency for large unsorted arrays. And the third one is average case time complexity. The average case complexity insertion sort is also 0 of n to the power of 2. The average number of comparison and shift required remain high even for randomly sorted order arrays. Insertion sort is generally not recommended for large database due to its quadratic time complexity and space complexity of insertion sort. The space complexity of insertion sort is 0 of n, as it only requires a constant amount of extra space for variables. It does not require any additional database to store element during the sorted process. This makes insertion sort space efficiency compared to other sorting algorithms like merge sort or quicksort. And next one is adaptive nature of insertion sort. Insertion sort is adaptive, meaning it becomes more efficient when dealing with partially sorted apps. In such case, the number of comparison and shifting is significantly reduced. This adaptability makes insertion sort a suitable choice for nearly sorted datasets. And stability of insertion sort. Insertion sort is a stable sorting algorithm, meaning it preserves the relative order of equal elements. Elements with the same value will remain in their original order in the sorted array. This property is important in certain applications when the original order needs to be maintained. Now we compare the insertion sort with other sorting algorithm. Insertion sort is less efficient than quicksort or merge sort for a large database. It performs well for small databases or nearly sorted arrays compared to other sorting algorithms. The choice of sorting algorithm depends on the size, nature of the datasets being sorted. What is the application of insertion? The insertion sort is commonly used in practice for sorting small datasets or when the array is nearly sorted. It is often used in implementation of other algorithm as a subroutine for sorting small subarrays. Insertion sort can also be used in online algorithm where data arrives in continuous stream. The next, improving time efficiency of improving insertion sort. One way to improve this time efficiency of insertion sort is by using a binary sort. Binary insertion sort reduce the number of comparison by using a binary search to find the correct position for each element. This approach can be more efficient for large datasets. Optimization insertion sort with shell sort. Shell sort is a variation of insertion sort that improves its time complexity by reducing the number of comparison and shifts. Shell sort divides the array into small subarrays and sort when they using a insertion sort. This can be significantly improve the performance of insertion sort for a larger datasets. Parallelism insertion sort. Insertion sort can be parallelized to improve its time efficiency and multi process by dividing the array into small subarrays and sorting them in parallel. The overall sorting time can be reduced. Parallel insertion sort can be advantage of modern computing architecture to speed up the sorting process. Fine. Conclusion. Insertion sort is a simple and easy to implement sorting algorithm with a time complexity of 0 of n to the power of 2. It is efficient for small data sets or nearly sorted arrays, but less efficient for large unsorted data sets. Understanding the time efficiency of insertion sort can help in choosing the appropriate sorting algorithm for different scenarios. Thank you.